Good morning, class. We are going to continue with 15.3. We will start off with problem number 3 on page 1025. We're going to shift our focus to stem and leaf plots to finish up 15.3. This is again another way that we can graph and analyze quantitative data. So if you take a look at the top, it says problem 3, let the games begin. At the 2010 Winter Olympics, 82 countries competed in the events, but only 26 won medals. By contrast, the 2008 Summer Olympics in Beijing, China had 205 countries compete in the events, but only 43 won at least 5 medals in various competitions. So take a look at the table that we have on page 1025. You can see the title is the total number of medals won by various countries. This is now in the 2008 Summer Olympics. So take a look at that with your group members. Let's take a look at the next page, page 1026, and what I would like you to do with your group members is answer questions 1 and 2. Number 1 says, what conclusion can you make between the number of medals won at the 2008 Summer Olympics and the number of medals won at the 2010 Winter Olympics? Now remember, this is the chart that was back at the beginning of 15.3, so that's the table that you're going to want to go back and refer to. Also then, I want you to answer number 2. It says, do you think using a dot plot would be a good way to organize and analyze the data in the Summer Olympics data table, and then explain your reasoning? So do that with your group members. So looking at the answers to number 1 and number 2, for number 1, hopefully you came up with the conclusion that there were a lot more events in the Summer Olympics because there were many more medals that were won than in the 2010 Winter Olympics. For number 2, do you think using a dot plot or line plot would be a good way to organize and analyze the data? Your answer for that would be no, because there is so much data and information in the table. There are a lot of data points that you would have to put on the line plot. Also, the number line would be very long. Your range would actually be from 5 to 110 because that's the lowest and highest data point. So hopefully that's what you came up with for your 2 answers when you discuss with your groups. So like you talked about with your group members, because there are many data points in the 2008 Summer Olympics data table, a line plot would probably not be a good graphic display of the data. A graphic display that can easily display all the data points is needed. A stem and leaf plot, make sure you highlight that, is a graphical method used to represent ordered numerical data. Again, remember, that's ordered numerical data. Once the data is ordered, the stem and leaves are determined. Typically, the stem is all the digits in a number except the rightmost digit, which is the leaf. If you take a look at the top of page 1027, it says a stem and leaf plot displaying the number of medals won in the 2008 Summer Olympics is shown. So take a look at that stem and leaf plot with your group members, and what I would first just like you to do is answer number 3, letter A. Use the stem and leaf plot and describe what you notice about the stem and leaf plot. Try to come up with a couple of things that you and your group members notice. Hopefully a couple of key things that stood out to you when you took a look at the stem and leaf plot with your group members. The stem and leaf plot has long lines of single digits that are in numerical order in the leaves column. Some of the numbers also repeat in that leaves column as well. So take a look at that leaves column, and hopefully that was one thing that you noticed. Also, there is a set of numbers that are in numerical order under the stems column as well, and you can see that those numbers are running vertically. That's hopefully the second thing that you kind of noticed. Third thing, there's the same number of leaves as there are data points in the chart about the Olympics. So all of the numbers in the leaves side of the stem and leaf plot represent all of the numbers that are in the list of data. Last thing then, hopefully that you notice down at the bottom, is that there is a key below the stem and leaf plot to give you an understanding of what each number in the stem and leaf plot represents. So go ahead with your group members then and finish up the rest of number 3. Take a look at letter B, C, D, and E and answer those questions. I'll give you a couple minutes. In looking at the answers then to B through E, letter B should have had 40 metals won. Letter C, that means that there were 5 metals won. There were 12 stems in the stem and leaf plot for letter D. And then for letter E, there are 43 leaves in the stem and leaf plot because that is the number of countries that are represented in the data. And like we just talked about earlier, remember that however many numbers are in the leaf side of the stem and leaf plot, that's going to represent the total number of data points that you see in the table. Go ahead and take a look at letter F and letter G at the top of page 1028 to answer those questions with your group members. If we take a look at letter F, it asks us, why do you think a stem has more than one leaf? A stem has more than one leaf because there are several pieces of data with the same beginning digit. So if you would refer back to the stem and leaf plot, you would see that there were a couple of countries that had 10 metals won, 11, 13, 14, and so on. So that's why there are many leaves representing that number 1 stem. As far as letter G goes, it says then, why do some stems have no leaves? Because in that case, there were no values for those stems in the Summer Olympics data chart. If you look at the 5 and the 6 in the stem part, representing any medals won that would be in the 50s and 60s, there weren't any countries that won those number of medals. So that's why that part of the plot is empty. Okay, the last thing that we're going to finish up with today then is, after skipping letter H, let's take a look at letter I down at the bottom of page 1028. It asks us to describe the distribution and any interesting patterns you notice in the stem and leaf plot. Interpret your findings in terms of the number of medals won in the 2008 Olympics. Now remember, when they're asking you for any interesting patterns, hopefully you're taking a look at clusters and gaps like we did back at the beginning with line plots, or dot plots that we called them back in the beginning of 15.3. So it'll take a couple of minutes to finish that up with your group members. The distribution of the stem and leaf plot would be skewed right because there is a peak at the lower end. You should hopefully see that there is a cluster of data from 5 to 47 metals. That cluster between 5 and 47 means most of the countries won between 5 and 47 medals. Lastly then, you should see gaps between 50, 60s, 80s, and 90s. Telling us that no one won that number of medals. Alright, let's finish up 15.3 with problem number 4 and take a look at interesting presidential facts on page 1029. It says the table shown lists the ages when 38 former presidents of the United States were first inaugurated president and the ages when they died. So take a look at that table with your group members. Let's take a look on the next page, page 1030, and look at number 2. It says, let's display the data of the age at which each president died in a stem and leaf plot. So before we actually construct it, go through with your group members and answer number 2, letters A through D. Take a couple of minutes to do that in order to make sure that we eventually construct our stem and leaf plot correctly. Alright, let's take a look at the answers that you came up with for number 2. For letter A, the stems that you want to use are 4, 5, 6, 7, 8, and 9, because those are the numbers in the tens digit in the table for all the ages of each president's death. If you take a look at letter B, you're going to use 38 leaves because there are 38 former presidents in the chart, and each former president listed has died. So that's how many that have died. There's 38 leaves in your stem and leaf plot. For letter C, you can refer back to letter A Those numbers that we wrote down, 4, 5, 6, 7, 8, there's going to be 6 stems. And the key that we are going to make for letter D, for instance, if we had 8 with a vertical line and a 0 after it, that would mean 80, which is going to represent the age at which the president died. So that's what you should have had for A through D. Hopefully this will help you then create your stem and leaf plot on the next page. Alright, we are going to use the stem and leaf plot. They already have a table made out for us on the bottom of page 1031. We're going to use letter F. We of course know that we want to make sure that our stem and leaf plot is in ascending order. So what I would like you to do with your group members is take all of the information and put it into a stem and leaf plot for the ages former U.S. presidents died. Take a couple of minutes. Alright, if we take a look at letter F, this is what our stem and leaf plot should have looked like. Remember, there should have been 38 numbers in your set of data. Everything should have been in ascending order. The stems were already put in for you. You just had to fill in the leaves. So hopefully this is what it looked like. Again, notice that there is a title. There's a key down at the bottom, 8 with a vertical line, and then the 0 after it is going to mean that that would be 80 years of age that the president passed away. One thing I want you to also take a look at is the distribution for the stem and leaf plot. In this case, what I want you to do is talk it over with your group members. Ask yourself what the distribution of the data is, and then also if there are any clusters or gaps in this stem and leaf plot. And that's what we'll kind of wrap up with to finish class today. Thank you.